Part 1 to 6 multiple choice questions, 0.5 mark each. 1. Using the appropriate number of significant figures, what is the result of 14.3 to 69.5684, div 5.840? A. 2.0. B. 2.4. C. 2.39. D. 2.388. Answer. The answer is C. 2.39. To find the significant figures, we need to count the non-zero digits and any zeros between them. In the numbers $14.30 and $69.5684, all the digits are significant. In $5.840, the trailing zeros are not significant because they are behind the decimal point and there is no decimal in the number we are dividing by. Following the rules of significant figures, the answer should have the same number of decimal places as the least precise number used in the calculation, which is $5.840, 1 decimal place. Therefore, the answer is rounded to $2.39. 2. The speed, v, of an object measured in meters per second is given by the following equation: v equals a plus b, t caret 2, plus cort caret 4, where t refers to time in seconds. What should be the units of a, b, and c respectively? A. Meter per second, m per square second. B. m, meter per square second, m per cubic second. C. Meter per second, m dot operator s, meter per second to the power of 5. D. Meter per second, meter per second, meter per second. Answer. The answer is a meter per second, meter per square second, meter per second to the power of 4. In the equation, $v is the speed in meters per second. To maintain dimensional consistency, the units of the terms on the right side of the equation must also be meters per second. A is a constant term, so it should have the same units as the speed, which is meters per second, meter per second. B has $t caret, minus $2, in its units. Since $t is in seconds, $t caret, minus $2, is equivalent to seconds squared, s squared. Therefore, B should have units of meters per second squared, meter per square second. C has $t caret, 4, in its units. Therefore, C should have units of meters per second to the 4th power, meter per second to the power of 4. 3. A car is traveling along a straight line, and its motion is given by the velocity graph shown. Which of the following statements is true about the speed and acceleration of the car? A. Its speed is increasing and its acceleration is also increasing. B. Its speed is decreasing while its acceleration is increasing. C. Its speed is increasing while its acceleration is decreasing. D. Its speed is decreasing and its acceleration is also decreasing. Answer. The answer is A. Its speed is increasing and its acceleration is also increasing. The velocity graph shows a positive slope, which means the car's velocity is increasing. Since the slope is also increasing, the rate of change of velocity, which is acceleration, is also increasing. 4. Which of the following is not true about freely falling objects? A. A freely falling object is moving under the effect of the force of gravity only. B. All freely falling objects have the same acceleration regardless of their mass. C. The acceleration of a freely falling object is directed always downward. D. The acceleration of a freely falling object at the top point of its path is 0. Answer. The answer is B. All freely falling objects have the same acceleration regardless of their mass. This statement is not true. Galileo Galilei discovered that all objects, regardless of their mass, experience the same acceleration due to gravity in a vacuum. This means, question 1, which of the following is true concerning vectors A, B, C and D shown? The answer is D, vec A plus vec B plus vec C plus vec D equals 0. This is because the sum of all the vectors shown forms a closed loop. In vector addition, when head-to-tail placement of vectors results in the starting point and ending point coinciding, the sum of the vectors is 0. Question 2. If vector, overline, A, equals 20 tilde x 15 tilde y, then the magnitude and directional angle of vec A are 2143 carat, circ. Answer. The answer is B, 25,143 carat, circ. To find the magnitude and directional angle of vector A, we can follow these steps. 1. Magnitude. The magnitude of a vector can be calculated using the formula $sqrt, A_x squared plus A_y squared, where $A_x and $y are the x and y components of the vector, respectively. In this case, $A_x equals $20 and $y equals -$15. Therefore, the magnitude $sqrt, 20, squared plus, -15 squared, equals $25. 2. Directional angle. The directional angle can be calculated using the arctangent function. $tan caret, -1. Left, dfrac, A_y, A_x, right, However, the arctangent function only outputs values between -$90 caret, circ $, and $90 caret, circ $. In this case, vector A lies in quadrant 2, so we need to add $180 caret, circ $, to get the correct directional angle. $tan caret, -1, left, dfrac, -15, 20, right, plus 180 caret. Question. A car starts from rest and accelerates uniformly over a time of 6 seconds for a distance of 110 meters. What is the speed of the car at the end of the 6 seconds? Answer. To find the car's speed, we need to use these steps. 1. Find the acceleration. We use the equation s equals ut plus 1/2 at squared. S, distance, equals 110 meters. U, initial velocity, equals 0 meter per second, since it starts from rest. T, time, equals 6s. Solving for acceleration, we get A equals 6.11 meters per square second. 2. Find the final velocity. We use the equation v equals u plus at. V, final velocity, equals u, initial velocity, equals 0 meter per second. Acceleration, equals 6.11 meters per square second. T, time, equals 6s. Solving for final velocity, v, we get v equals 36.67 meters per second. Therefore, the correct answer is D, 36.67 meters per second. A particle moves in the xy plane with a constant acceleration of 5x2y meter per square second. If the velocity of the particle at a certain moment is 8x plus 13y meter per second, what is its velocity 4 seconds later? Answer. We can find the particle's velocity 4 seconds later by separately considering its motion in the x and y directions. 1. Separate x and y components. Acceleration. A_x equals 5 meter per square second, in the x direction. A_y equals -2 meter per square second, in the y direction, negative sign indicates downward acceleration. Initial velocity, v_x equals -8 meter per second, in the x direction. v_iy equals 13 meter per second, in the y direction. 2. Use constant acceleration equations. We can use the following equation for each direction to find the final velocity components, v_f, after 4 seconds, t. v_f equals v_i plus a*t. 3. Find final velocity components. Final x velocity, v_fx, v_fx equals v_x plus a_xt. v_fx equals -8 meters per second, plus 5 meters per square second, 4s. v_fx equals 12 meter per second, positive value indicates rightward motion. Final y velocity, v_fy, v_fy equals v_iy plus a_yt. V underscore Fy equals 13 meters per second, plus, minus 2 meters per square second, 4s. V underscore Fy equals 5 meter per second, positive value indicates upward motion. 4. Combine final velocity components. The final velocity, v underscore f, after 4 seconds is the vector sum of v underscore fx and v underscore fy. V underscore f equals 12x plus 5y meter per second. Therefore, the particle's velocity 4 seconds later is 12 meters per second in the positive x direction and 5 meters per second in the positive y direction, which can be written as 12x plus 5y meter per second. One of the solutions. Problem 3, projectile motion. Understanding the problem, we have a ball thrown upwards, and we need to find the time it takes to hit the ground. We'll use the principles of projectile motion to solve this. Solving the problem. 1. Break it down. The motion has two parts, upward and downward. 2. Upward motion. Initial velocity, v0, equals 17.6 meters per second. Final velocity, vf, at maximum height equals 0 meter per second. Acceleration, equals minus 9.8 meters per square second, due to gravity. Use the equation, vf equals v0 plus at to find the time to reach maximum height, t underscore up. 3. Downward motion, initial velocity, v0, equals 0 meter per second, starts from rest at the top. Displacement, d, equals minus 20 meters, negative since it's downwards. Acceleration, equals minus 9.8 meters per square second. Use the equation, d equals v0t plus 1/2, at squared to find the time to fall, t underscore down. 4. Total time, t underscore total equals t underscore up plus t underscore down. Calculation, following the steps above will correctly lead you to the answer. The correct answer is D, 4.0s. Problem 4, vector magnitude. Understanding the problem, we're given two vectors A and B, and we need to find the magnitude of a new vector C, which is a linear combination of A and B. Solving the problem. 1. Calculate C. C equals 2A 5B equals 2, 7x 11y, 5, 3x 8y. Simplify the expression for C. 2. Find the magnitude. The magnitude of a vector v equals vx, vy, is calculated using v equals square root vx squared plus vy squared. Calculate the magnitude of vector c. Calculation. Following these steps will correctly lead you to the answer. The correct answer is B, 34.1. Let me know if you'd like a step-by-step calculation for either problem.
Part 3, Problem 1. Problem 1. To solve this problem, let's analyze the given velocity time graph. A. The object is moving with the positive acceleration when the velocity time graph has a positive slope. Looking at the graph, the object has a positive acceleration during the time interval t equals 0 second and t equal 4 second. B. To find the distance traveled by the object between t equal 2 seconds and t equal 12 seconds, we need to find the area under the velocity time graph within this time interval. Since the graph represents velocity, the area under the graph represents displacement. The area under the graph between t equal 2 seconds and t equal 12 seconds is trivialized. The formula for this area of y is given by area equal half sum of parallel slides multiplied by height. From t equal 2 seconds to t equal 4 seconds, the velocity is 4 meters per second. And from t equal 4 seconds to t equal 12 seconds, the velocity is 8 meters per second. The height of trapezoid is 12 minus 2 equal 10 seconds. area equal half multiplied by 4 plus 8 multiplied by 10 equal 10 meter, 60 meter. So the distance between traveled by the object between t equal to second and t equal to one second is 60 meter. C. Average accelerations between t minus 8 second and t equal 16 second can be calculated using the formula average acceleration equal change in velocity over change in time. From t equal 8 second to t equal 16 second, the change in velocity is 12 meter per second minus 8 meter per second equal 4 meter per second, and the change in the time is 16 minus 4 second equal 80 seconds. Average acceleration equal 4 meter per second over 8 second equal 0.5 meter per second square. So the average acceleration of between t equal 8 second and t equal 16 second is 0.5 meter per second square. D. The instantaneous acceleration at t equal 1 second can be determined from the slope of the velocity time graph at that point. Since the graph is linear, the slope is constant, meaning the acceleration is constant. The slope of the graph can be calculated as the change in velocity divided by the change in time. From t equals 0 at t equals 4 seconds, the change in velocity is 8 meter per second minus 0 meter per second equal meter per second, and the change in the time is 4 second minus 0 second equal 4 second. Instantaneous acceleration equal 8 meter per second 4 over meter per second 4 meter per second equal 2 meter per second squared. So the instantaneous acceleration of this object at t equal 1 is 2 meter per second square. Problem 2. To solve this problem, we can use the equations of motion for projectile motion. Let's denote h at the height of the building, 44.1 meter. T had horizontal distance from the building base, 120 meter. T at the time taken for the stone to hit the ground. V naught at the initial horizontal velocity of the stone. Vf at the final velocity of the stone just before it hits the ground. D the acceleration due to gravity approximately 9.8 meter per second square. To find the time it takes for the stone to hit the ground, we can use the formula of the vertical motion. H equal half gt squared. Solve for t. T equal square root 2h over g, plugging in the values. T equal square root 2 multiple 44.1 over 9.8 equal T equal approximately square root 24.2 over 9.8. T equal root of 9 equal 3 centimeter, 3 second. B. To find the initial horizontal velocity V naught, we can use the formula of horizontal motion. D minus V naught T. V naught equal D over T, plugging in the values. V naught equal 120 over 3 equal 40 meter per second. C. To find the velocity V naught Vf of the stone, V final, V velocity final of the stone just before it hits the ground, is equal to its initial horizontal velocity because there is no vertical acceleration acting with the stone. Vf equal V naught equal 40 meter per second. D. To find the angle of impact with the ground, we can use trigonometry. The horizontal velocity remains constant throughout the motion. The vertical velocity increases with the time due to the relation of gravity. Tan theta equal V f Vx 0. Since the stone is thrown horizontally, the initial vertical velocity is 0, and Vx equal V naught equal 40 meter per second. Theta equal time minus Vy, Vx equal time minus theta gt over Vx0. Plugging the values, theta equal time minus 9.3 multiplied by 3 over 40. Theta equal time minus 1, 0.73, nearly equal 36.33 degrees. So the angle impact with the ground is approximately 36.83 degree.